In this video, we'll be learning about frequency distribution in graph. We need to understand the concept because when conducting a statistical research, investigation, or study, the research must gather data for the particular variable under investigation. For us to describe situations, make conclusions, and draw inferences about events. The research must organize the data gathered in some meaningful way. From that, I will be discussing to you the easiest way and widely used organizing data, which is the frequency distribution. To define first the frequency distribution, it is a grouping of the data into categories showing the number of observations in each of the non-overlapping classes. Okay, from this definition, we know that after organizing the data, the next move of the researcher is to present the data so they can be understood easily by those who will benefit from reading the study. And one useful method of presenting data is by constructing a graph and charts. There are several ways to plot the graph and charts, and each one has a specific purpose. Now let's define first some technical terms in this topic. So we have the raw data. It is the data collected in original form. For example, if you want to determine the mean score of the students in their periodical test, then the raw score is the scores of the students in that particular test. Next is the range. It is the difference of the highest value and the lowest value in a distribution. It is computed by R equals HB minus LV, where our HB is the highest value and LB is our lowest value. The next is the frequency distribution. It is the organization of data in a tabular form using mutually exclusive classes showing the number of observations in each. And that frequency distribution is the thing that we need to make this in this topic. Next is the class limit. Is the highest and the lowest values describing a class. Say, if your class limit is from 10 to 15, then your lower class limit is 10, and then your upper class limit is 15. Next is the class boundaries. Is the upper and the lower values of a class for a group frequency distribution whose values has additional decimal place more than the class limits and end with the digit 5. So you just need to subtract your lower class limit by 0.5, and from 10 will give us 9.5, and 15 will give us 15.5. The corresponding class boundaries for that class limit of 10 to 15 is now 9.5 to 15.5. Next is the interval. It's the distance between the class lower boundary and the class upper boundary, and is denoted by the symbol I. So since our class boundary is 9.5 to 15.5, we just need to subtract 9.5 from 15.5, and that will give us I equals 6. And 6 is now the interval of our class limits, right? Next is the frequency denoted by the symbol F, is the number of values in a specific class of a frequency distribution. Okay, that is based on the tallied frequency of the data. Then relative frequency or RF is the value obtained when the frequency in each class of the frequency distribution is divided by the total of values, and that is relative frequency. Then percentage, you just need to when you multiply the relative frequency by 100%, and that's already a percentage. Then next is the cumulative frequency, is the sum of the frequencies accumulated up to the upper boundaries of the class in a frequency distribution. And we'll just have our example for this part. Then midpoint is the point halfway between the class limits of each class and is representative of the data within that class, or meaning it is the middle of the class limits, or simply the average of your class limit. Now let's move on to constructing frequency distribution. A group frequency distribution is used when the range of data is large. The data must be grouped into classes, whether it is categorical data, interval data, or numerical data or ratio data. For categorical frequency, it is used to organize nominal and ordinal type of data which is under categorical. Some examples we can apply in this distribution are gender, business type, ranking of performances, political affiliation, and so on and so forth. These are examples of categorical data. So you have there an example, 20 applicants, just take out the last part class. It's just the repeats of the row 4. Okay, just take out the last row. There are 20 applicants who were given a performance evaluation appraisal. The data set is high, average, low, low, high, low, average, low, dot until the last column, average, average, high, and high. Okay, then construct a frequency distribution for the data. Step 1, you need to construct a table as shown below. On the first column, you have there the class, second column tally, third column frequency, and the last column is percentage. And under the column of the class, you have there the high, average, and low. In our data, we have, in step 2, we can now tally the row data. We get for high, we had 7. For average, we had 8. And low, we had 4, a total of 20. Then, step 3, we need to convert the tally data into numerical frequencies. So, 7, 8, and 5 respectively. And step 4, determine the percentage. The percentage is computed using the formula F over N times 100, where F is the frequency of the class and N is the total number of class, a total number of values. Then there you can just have 7 divided by 20 times 100, and that is now equal to 35%. Okay, the next is 8. 8 divided by 20 times 100, and that will give us 40%. And next is 5 divided by 20 times 100, and that will give us 25%, a total of 100%. And for that sample, more applicants receive an average performance rating. So meaning the highest percentage obtained is average.